Well, chemistry, Mr. Singer here with lab for today, and this one is the sodium bicarbonate and acetic acid lab, and we're going to do part 1. So this is the exact same chemical reaction that we used to do the hot ice lab, and it says we're going to mix 7 grams of sodium bicarbonate into a 150 milliliter beaker. So here's our sodium bicarbonate, baking soda. And so we're going to measure that into the beaker. Okay, there's about 7 grams of baking soda, and then it tells us to put about 100 milliliters into the beaker. And so we're going to do that with vinegar, acetic acid, okay, then it says that we're going to measure the mass of each of these beakers. So you've got some blanks here. I want you to put in here the mass of each beaker, because we're going to look at how much mass we started with and how much mass we're going to end with. So this beaker is 96.45 grams. And then this other beaker is 194.65. Now, it says to mix slowly. By the way, you're going to put each of the individual masses here and then put a total over here. So it says to mix slowly, and that's exactly what we're going to do. This is the same one we had for the hot ice, and it's so easy for it to be boiling over. So I'm not going to talk while I'm stirring so that we can speed up the video. Okay, so then we're going to measure the mass of them each after. So here's the vinegar beaker, which is 189.22, and the baking soda beaker is 98.70. That actually was the opposite. It doesn't matter too much, but the empty beaker is 98.7, and the mixture is 189.22. So add those two up together and get a total. Now, it's going to be less. I want you to tell me how much less, what's the difference in the mass, and then why is the total mass different? Well, what were all these bubbles that were coming off of our mixture? The bubbles are carbon dioxide. As it says here in our chemical reaction, it tells us that the product of mixing these things together is water and carbon dioxide. And so the carbon dioxide is a gas and is bubbling off and leaving the environment. So it doesn't add any mass to our beaker, it actually takes it away. So that is what's happening in the first part of part 1, and now we're going to go into part 2. Here we are again on sodium bicarbonate and acetic acid lab. We're going to do part 2, and it tells us to put 7 grams of baking soda into a bag and put it in the corner. Then we're to measure 100 milliliters of vinegar. I'm going to try to put it in the other corner without it mixing. So to do that, I'm going to fold up this side of the bag. I'm going to roll it up so it doesn't get away from us. And then I'm going to try to pour 100 milliliters into this corner. And our goal here is to have them both in the same bag without mixing. So I'm going to get that beaker to hold it for me. I'm going to try to squish out all the air that I can. And then I need to find its mass. So we got to find the mass of this before its reaction. So I'm going to put this beaker on the scale. I'm going to tare it. Let's make it go to 0. And now I'm going to add this to the scale. And so the mass of this bag before the chemical reaction is 111.67 grams. All right, so now I'm going to take it out of here and we're going to shake it up. We're going to put this stuff together and watch it react. And you'll see that so you'll see that the bag is actually sort of inflated some. We'll come back to that. Now let's check our final mass. So our final mass for the bag is, well, before I tell you, you expect it to be the same mass, different mass? Is it going to be lighter, heavier? Well, we trapped all the carbon dioxide. That's what filled this bag with gas, is the carbon dioxide, filled it up. So we kept all the mass in here. We didn't let it get away from us like we did in the first part. So you'd think that it should be the same mass, but the scale tells us that the mass is 109.88 grams. 109.88 grams. Well, where did the other mass go? Because the first mass was 111, now it's 109. About 2 grams are gone, it seems, even though we kept the bag ziplocked shut. So where did it go? Well, here's the answer. It's still here. But why is it that a helium balloon goes up? It's because it's less dense than the air that surrounds it. When the carbon dioxide went from being part of the baking soda and part of the vinegar, when it became a gas, that made it less dense. And so in fact, the air around here is helping lift up this bag, and it's actually lifting this bag with 2 grams of force up because the carbon dioxide is less dense than it was as a solid. So atmosphere actually lifts things up. Now it's not enough to make it float like a hydrogen balloon, but it is 2 grams lighter, at least on the scale. The same mass is here, but the scale feels like it's 2 grams less. And that concludes the first part of the sodium bicarbonate and acetic acid lab.